Hi, we are going to talk about computer hardware. Computer, you can consider four components. One is input, output, CPU, and storage. Input, the keyboard. Output, the monitor. CPU, your CPU chip for processing. Storage, your memory to keep your work. That's four components of your computer. You can also view computer from hardware and software point of view. In addition to hardware and software, you may also heard the term firmware before. So what's firmware? Or go to the basic, what's hardware? What's software? Hardware like the keyboard, like the monitor, that's the hardware. So what's the software? Software like PowerPoint presentation software. With that presentation software, you can come up with PowerPoint slides. Without that PowerPoint software, you cannot do it. When you get yourself a new computer, we're not talking about Apple computer, we're talking about non-Apple computer. Now you get yourself, say, a Dell computer. It comes with a operating system. That's Windows 10, Microsoft Windows 10. It does not come with PowerPoint software. PowerPoint software belongs to the family we call Office, like Office 2019. So what can you do? You have your Dell computer, a new one, with Windows 10 operating system, but no PowerPoint software. You need to pay money to get a software. One way is to get your Office 2019 installed into your computer. Software, you cannot see it, you cannot touch it. But when I said you cannot see it, you cannot touch it, that's a figure of speech. You can actually see it when you are making some PowerPoint. You see the PowerPoint? That's based on your PowerPoint software you have. Then you come up with your own PowerPoint slides. So when I say you cannot see it, software, you can see it in this way. And hardware, you can touch it. So that's the difference between a hardware and a software. A computer with hardware and no software, it's pretty much useless. The other way around, you have the PowerPoint software, you don't have a computer, then where are you going to keep it? So software is the app, application you're going to use, and hardware is the items who can keep your software works here. You can consider like hardware is a tool. You want to go outside and cut a tree. This is an analogy. Don't really go outdoor and cut a tree because Dr. Wu says so. Now you get yourself into trouble. Give you an analogy, example, try to explain to you what is hardware, what is software. Now you have yourself a chainsaw, a handsaw, that's your hardware. You can tell me right away which hardware is more powerful. The chainsaw, the handsaw is not good enough. You want to cut a big tree, it won't work. So hardware, they have some powerful hardware, not so powerful hardware. And then software, that's your skill. You have a handsaw, you want to cut a tree. The skill you have going to make it happen. If your skill is very bad, you may hurt yourself. And if your skill is very bad, you use a chainsaw, you're going to hurt yourself even worse, much worse. So that's the stuff here. When you have a more powerful computer hardware, you surely can do more job or more damage. One example, senior citizen. Phone company have a phone. That phone only can use to place a phone call receive a phone call, that's about it. That's all the senior citizen needs. Some senior citizens need. You make it very, very fancy. They can go to social media. If this person have some problem and go to social media and post a lot of inappropriate message, then you're going to don't feel good about that. So in this case, we would like to limit the function here. And only need someone to call you, and someone, you want to call someone, and one thing you will need is GPS. Then we know your location. When you need help, we know your location. We call you, you have no response. Whoa, we're going to, based on the GPS location, try to find you and see if you are in trouble. So that's the use here. Now we're talking about hardware, software, and you're talking about application. That application is software. So that's the thinking we're going to make. And firmware is a kind of software you're going to use a lot. You can burn into a chip. We'll call it firmware. Why would I want to do that? I mean, hardware, software works. Yes, works, yeah. But this software, you want to use a lot. You want to make it faster. You burn it, make it a firmware. Then that looks like hardware. It's much faster. You can consider the firmware is like a shorthand. You say AKA, also known as. Okay, so IE, that is. So something like that. You got yourself some shorthand, that will be easier. So that's your firmware. And like we have many, many terms turn out to be like firmware terms. You go to a garage, a car dealer, you want to do an oil change. That oil change is like the firmware idea. And they need to open it up, the oil, the engine oil, and drain it out and put into a new one based on your car, your model, different type of oil, and do it here. But that kind of stuff here, you don't want to say that, hey, drain my engine oil and fill in with new engine oil. You don't want to say that. You just say oil change. Same idea for firmware. Would you say that oil change is easier and is faster comparing to drain out my old engine oil, fill in new engine oil? Of course it is. That's the firmware. We're going to see more and more use of firmware here. Hardware, software, and firmware. Considering the hardware, I'm using the iPhone as an example. Your iPhone, little bit tiny device, and accommodate lots of functions here. That's the hardware. They make it very, very thin. They make it very, very small, very, very tiny. It's very, very difficult. It's a challenge of hardware. It's not really a software challenge. It's a hardware challenge to make a new iPhone. And also, with the iPhone as an example, the battery, because the CPU, they have dual CPU, meaning they may have more than one CPU. And that CPU, you're going to have a fan to take out the heat. When the CPU is working, generate the heat. Just like your car engine is running, you have a fan, you have a cooling system to cool it down. Same idea. And you have battery here. You have a car battery, right? Yes, we all know that. And your mobile phone have a battery. And you run out of battery, you need to recharge. So the battery here, it's also generate heat. It may burn your face when you use a mobile phone. Should that mobile phone has not been well designed? That's a challenge. That's your hardware, software, and firmware. Don't ever forget the apps here, application. What do you want to do with this hardware, software, and firmware? What are you trying to do? So that's most important. If there's no app, that's useless. That's useless, totally useless. Hardware you can consider like a highway. Yeah, we got a highway. And software you can consider like the sign. You have all the sign. Should there be no sign, you want to drive from Dallas to Houston, guess what? Well, you are on yourself. You don't know where or which highway you want to take, where you want to make a turn. You have no clue whatsoever. So they need to give you some sign. You can consider those signs like software. Then what is the application? 18-wheelers, sedan, motorcycle. Without the vehicles, then the highway is useless. You have hardware, but nobody uses it here. So that's a big waste of money. Application, in this case, is the king. I have always tried to say that content is the king, or use a different word. Applications is the king. You want to be based on your application, then change your hardware, change your software, change your firmware. That's most of the time. It happens to be that way. Okay? Think we have enough idea about hardware. I can add a little bit more about hardware. So some people like to buy a notebook. Other people may want to have a desktop computer put on your desktop. Notebook is portable. That's good. Desktop is not portable, but they have some pros and cons. Like the desktop, they may have better audio function, better recording function. And whenever you get some problem, you open up that big system unit, fix it. People can fix that for you. Notebook, they open up your notebook and try to fix it. They may damage more than they can fix the problem portions. So typically, when you have a notebook, you get a serious problem. If you have a battery problem, change a new battery, no problem. Otherwise, most likely they're going to ask you to buy a new one. That's a pros and cons. Money talks. And considering idea here probably is you need to have a desktop, you need to have a portable notebook. You have both. So for different purpose. One you bring to school, the other one you stay home and use it. You got two computers. Nothing wrong with that. Computer nowadays, the price is getting less and less costly. So this is the hardware. You see this picture here? This is the CPU, Central Processing Unit here. The CPU, and they have many little bit tiny wire. This is the metal wire here. That's how one component of hardware talk to another component of hardware. This is wiring. Yeah, this is motherboard, CPU, hardware. Now, inside the computer, if you use a desktop, we have system unit. You don't want to use the wrong term, say that box here. Well, I get my computer, something wrong inside of that box. What box? Packaging box? What box here? So that stuff, we have a technical term we call system unit. You open it up, the system unit, you're going to see a motherboard. You see that piece of metal, I don't want to call motherboard. I want to call something else. Try it. You can, but nobody knows what you're talking about. IT, computer, is term-based. You need to use the terms most people know. We have a consensus for those terms. Then you need to use those terms. You cannot create your own term. If you create your own term, there's no communication between you and the rest of the users in the world. It won't work that way. Inside the computer, talking about inside of your system unit, you can see, basically you can see a motherboard, a CPU. Next to your CPU, you see a fan, just like your car. Hey, open up the hood of your car, what do you see? You see an engine. In front of the engine, what do you see? You see a fan. You see a cooling system. Your car uses a fan and a cooling system to cool down the engine. How about your computer? You have a CPU, just like your car engine. What do you use to cool down your CPU? We don't have any cooling system here. Use a fan. Should the fan malfunction, your fan is not working, what's going to happen to your computer or to your CPU? Will that burn your CPU? No, it won't. The computer will automatically shut down, turn off, power off. You cannot use the computer. We want to protect the CPU, not protect your work. You say, I am in the middle of something. I almost finished my assignment. I haven't saved it. Let's see the priority. Priority is we let you continue using this overheated CPU because the fan is not working. That may burn out the CPU. Or we just shut down on you and you need to redo your assignment. Let me think. Eeny, meeny, miny, moe. I'll go with protect the CPU. How about you? That's the way we design. As I mentioned previously, the most important is apps. Considering the apps is what you want to do. Then, based on the apps, you design the hardware and software. Computer software has been designed this way. If overheated, your computer will be turned off to protect CPU. How about car? You're driving a car. Is the car same idea? No. If your coolant is leaking out of all the fluid, if your fan is not working, can you burn your engine of your car? Yes, you can. Sometimes you saw a car that smoke. I smoke my engine. Yeah, it's not a computer. Based on application, based on what we want to do here, we want to protect you, the driver. We don't want to protect the car engine. Well, the car engine is expensive, several $1,000s. That's very expensive. Why don't you protect that expensive engine? We believe your life is more important comparing to that engine. Would you say that? You're driving in a highway, 75 miles per hour. If so designed to protect the engine, suddenly you're going to lose power. The engine is not working anymore. You lose power. You're in the highway. Whoa, you have to turn to the side and stop it here. The traffic, there are some other cars. Can you do that? Based on your luck, sometimes you cannot. We don't want to risk your life to protect the engine, but we do want to risk your class assignment when you are using a computer to save the CPU. So that's the difference here. Thinking about your class assignment, thinking about your life, which one is more important? You know it now. So you know the basic design for the computer, hardware, software, firmware, they are all based on the application. They need to prioritize which one is more important. Then they design that way. Yeah, that's fine. System unit, as I mentioned, you get your desktop computer, you have something we call system unit, this box, and inside they have a motherboard. And somewhere in the motherboard, they have a CPU. Closer to the CPU, there's a fan. Well, this shows you the system unit. They also show you this Apple computer or this non-Apple computer. It doesn't matter. The difference between an Apple computer and non-Apple computer, that's number one, operating system. If you use a non-Apple computer, most likely that's Windows 10. You always have a choice to load Linux. If you are very good about computer, hey, I know everything about computer, I'm so good, then you know Linux. I also teach Linux. You load Linux operating system. You don't load Windows 10 operating system. Apple computer comes with Mac OS. Long time ago, Apple computer have a computer they call Macintosh. No more. That's the PC. Macintosh, they kind of like the term. So the term has been used nowadays called Mac OS. The app software are different. Use the Windows, you have PowerPoint to come up with slides. Using an Apple, they have different software application to come up with slides. So you don't call it PowerPoint. PowerPoint is a Microsoft term, but we don't really care that much. So they are not compatible. One is Apple company and one is Microsoft company. They are not compatible. Most of the companies, they use Microsoft. We'll say like 85%, or if we do that way, say 10% use Apple computer, 5% use Linux. The school, we are not going to teach you the best operating system. That's not a point. Which one is the best? We may have or may not have consensus. We're going to teach you the most widely used operating system. Then you graduate from school, you work for a company. Most companies use this operating system. You need to know. Linux may be the best operating system comparing to Mac OS, comparing to Windows. It's much more secure. You have fully control. It costs you nothing. It's free. But we are going to teach you Windows. Most computers in the world use Windows. Do we still have a Linux class? Yeah, we also have a Linux class. You need to know Windows. If you want to learn more advanced, then you can learn Linux. That's your Apple computer. This is non-Apple computer. System unit for desktop. We call this box a system unit. They're telling you there is also a all-in-one system such as iMac. This all-in-one system is they are putting this system unit as a portion of your monitor. So you may have a thick monitor, big, heavy monitor. That's you have your system unit inside. Then in this case, you don't have system unit. But that guy, see the stand here, is still a desktop. It's not a notebook. It's not for you. It's not portable. So that's a different system. And as I have mentioned to you, technically we can always already it's ready, but don't know when the business decision will go for it. All you need is a monitor and a keyboard. The system unit have CPU for processing, have a memory for storage. You don't need it. Can be a cloud. Later on, we may see a cloud computer. All you have is a monitor and keyboard and a software to connect to internet. Once you connect it to internet, if you are Apple user, based on your profile, you are going to use your computer like Apple. If you're a non-Apple user, Windows user, you're going to use your computer like Windows. If you're a Linux user, based on your profile, you're going to use your computer like Linux. Pros and cons here. Pros is, well, you don't have that much of devices. Your computer is much lighter. You can choose. If you know those 3 operating systems, you can easily change and use all of them. Cons. The processing and the storage are cloud-based. So what is a cloud-based? Cloud is internet. An internet service provider, a company, they're going to do that kind of service. Be careful, since day one, we have phone. That's like 1900, 1920, we have phone. We use the term called service. Service doesn't mean free. Service means the phone company going to give you something, you need to pay money to give it. And you are the subscribers. So that's service. Your cloud service provider, and you are a cloud service subscriber. Your info are all kept under the cloud servers. Servers looks like computer. The cloud, I saw the cloud, is actually have a physical location, maybe in Austin, maybe in Dallas. We don't know, and we don't care. It's transparent to us. It got nothing to do with us. As long as the cloud service provider can protect your information, good. You don't have any problem. But can this be guaranteed? I don't know. In reliability or availability, when you want to use it, they are in a maintenance phase, or they have some hiccup, they have some problem, the system is down, then you cannot use it anymore. Comparing to the legacy, that's what we have, computer nowadays, everything you have is here. You don't need to connect to internet and use it. One example is the Office. Office have Word, Excel, Access, PowerPoint, Outlook. There are 2 ways for you to get Office. One is buy Office 2019 software from Microsoft. It costs you $75, something like that. You load it to your computer, it's there. You don't need to connect to internet. Another way is via school to get your free Office 365, which the term tells you 365, that's a year, right? As long as you connect to internet, you can use it. And I have both. For this free, Microsoft offered to the students in the school. That's PowerPoint, Word, Excel, Access, Outlook. You can have a problem. Sometimes I got a problem when I use Office 365, slow. Internet, traffic jam, slow. Sometimes internet is slow. We all know that. Same idea. You have a PowerPoint assignment you need to come up with to turn it in. You have Office 365. Internet is slow. Then you need to wait. You have Office 2019. That's inside of your computer. That's not shared. You don't need to wait. That's a difference. That's a very, very good example talking about a cloud here. Today we have both. For Office, we have a cloud-based or PC-based. Later on, should we only have a cloud-based, we really need to make sure the internet is always available, always fast, and always secure. That's the 5G, mobile phone 5G, trying to do for us. It's a big challenge. Can they guarantee? I don't think anyone can guarantee about that. 100% of the time it's available. Even the phone system nowadays you used to call 911, right? You need to call your friend. And that system is 5.9. It's 99.999. You do a calculation, that's maybe about 5 minutes downtime allowed for the phone company. Most likely, they're not going to down for 5 minutes. They may have hiccup, like 3 seconds. You cannot use the phone. Then you dial again after 3 seconds, or later on, 10 seconds. Accumulated cannot exceed like 10 minutes or 99.999% you need to guarantee. Otherwise, FCC will charge you money for penalty and also can ask you to shut down your business. You cannot do a business. You're a phone company. But if you cannot guarantee 99.999, that's 59% of the time your phone system will be available, you may not be allowed to continue this business. So this is seriously. We're taking this seriously. But with that being said, we're not saying 100%. Hey, computer, machine, we cannot guarantee 100%. We really wanted to, but still, no, something may happen. Okay. Talk about some terms. They have a driver's bay here, like your DVD drive. DVD, long time ago, or used to be, if you have a notebook, it comes with a DVD player that's built in, a DVD player. You don't need to buy yourself a DVD player. But nowadays, the new notebook, they are much thinner and maybe cheaper. They don't have a built-in DVD player. You want to say, hey, I want to buy a notebook. I want to view DVD with a new notebook. You cannot. You have to buy an external DVD player, something like that, external DVD player, and hook it up to your notebook. The change, that's not the technology change, that's the business decision. They're thinking about less and less people viewing DVD and more people just viewing movies from the internet. Then with that change, they have changed the notebook design. Today, notebook design does not include a DVD player in your notebook. Power supply, this is very important. You have two power supply, one's AC, one's DC. AC is the wall outlet, that's your AC. And DC is your battery. Your notebook comes with a battery. The battery may last 4 hours, 6 hours. You better hook up to the wall outlet. When you are hooking up to an AC, it will keep charging your battery. If you don't do that, you run out of your battery. You don't have a battery, you don't have a wall outlet, you can do nothing. Your computer, there's no power here. So that's the power supply. Using the phone company is the same idea. The phone company, they have the AC power. They also have a DC backup power. Say, should there be a thunderstorm, a flood, a tornado, disaster, cut down the power. The phone company's system, they have a battery to back it up. How long the battery can back up the system? Maybe 12 hours. Then within these 12 hours, you need to have workers to fix your power supply. Otherwise, you run out of power. I still remember sometime happened in some city like Chicago, they have a blackout, there's no power. Something happened anyway, there's no power in some city. My friend there used a mobile phone to call me. And no power, your freezer, hey, your food, your oven, hey, you cannot use it. So friend called me using a mobile phone, a different system. It's not a home phone system. The home phone, there's no power. After, say, 12 hours, it's totally dead. Then use your mobile phone. mobile phone tower to call me and says, hey, what are you doing? We are barbecue in our backyard. Say, why you call me? Why you are barbecue in your backyard and call me? It's not weekend. So that's what happened. When we lose the power, that's what we do. Cooling fans here. I have explained the cooling fans to you already. You have a fan to cool down your CPU. If the fan is not working, the computer is going to be turned off automatically to protect your CPU. So if you have a computer keep turned off on you, you may want to check the fan. Motherboard is this is the motherboard here. They have all the device. Basically, they have a CPU and they have some audio device. That's a sound. And you can record, you can hear the sound. The video device, that's for you to see. And memory. You're working on your PowerPoint assignment, you can keep it there. They have two types of memory. One is the CPU memory. One is for the user memory. Like user memory, that's a term I just created. Don't use it. Nobody understands what you're talking about. One is RAM and ROM. That memory space is for CPU. It's not for you. You get yourself a new computer. They tell you our RAM and ROM, or we have a cache memory. That's very big here. That tells you the CPU can do very fast. And they tell you we have a C drive. It's very big. That's for you to keep your homework, movies, and everything you want to keep. That's two different types of memory. People may use storage or memory, those two terms, interchangeably. The RAM and ROM for CPU. CPU is a processor. Need to have a memory. You are writing your resume. Your info will be in the RAM and ROM. Well, RAM and random ROM here. ROM, read-only memory, that will have your Windows 10. And RAM, random access memory, that will have your resume you're working on. So that's different. That's why the CPU uses two types of memory. One to keep operating system, one to keep your work. And that RAM and ROM is so different. If you lost your power, so you are working on your resume, and I go there, unplug your computer, guess what? You're going to complain to me. Say, hey, Dr. Wu, why you do that? I'm working on my resume. I have not saved it. Now you see, I have to redo it. Because your resume is kept in the RAM, random access memory. Why don't you complain to me saying, why you want to do that? Now I have to reload the Windows 10. Your Windows 10 is in ROM. That's not anything you can see it or you can change it. It's not going to be power off, you lose it, that kind of a deal here. So that's the difference. They have two places here. Using an analogy here, say you are a cook. You're a very good cook. Yeah. So, now I need to give you a place for you to cook. Should I give you a little bit tiny space for you to cook? You're not going to be cook very, very fast because you don't have a space. You have to do the swapping stuff here. You put a little bit of food here and do a little bit and keep changing on some food. Or I give you big enough, you can keep the needed food all in there, ingredient all in there, then you can do it. So that's the difference. That's why we say that if your RAM and ROM is kind of small, even you have fast CPU, it won't work, right? So the CPU, that's like that. And you're thinking about memory, storage, that's a space. How come the space got anything to do with speed? Yes, I give you an analogy. You have yourself a sports car. That's a highway. They forget about the regulation for a while. We are talking, we are not actually doing it. So we're just talking. In theory, it's not in reality. Can you drive very, very fast? Highway, sports car? Yes and no. Yes, there's no car, no other cars. No traffic jam. There's traffic jam. You don't have enough space. Then you have a sports car, you're going to drive very, very slow. So the CPU and memory, they're working together here. You want to have a fast computer, you need to have a fast CPU and big enough memory. Okay, I guess you understand what I'm trying to tell you. And this is a chipset, computer chip here. Expansion card here. Long time ago, we are using expansion card to improve the performance, video or sound here. Yep. And long time ago, just like you see here, the left upper corner, that's your expansion slot. The book tells you you can put something here to improve your video, improve your audio. Mostly, the gamers who play computer games, they want to do that. Or if you're a heavy movie viewer, you want to do that. Long time ago, they also to expand the memory. I have opened up the system unit for my student all the time to put a new, you go to like Fry, buy yourself a new memory card, put under expansion slot. Memory is not big enough. User memory is not big enough. Well, I got too many photos, too many files here, too many movies. I am run out of space. That's what we do. Nowadays, mostly not. Company have give to you big enough memory. You say, no, not big enough for me. How about cloud memory? They ask you to put your pictures under the cloud. They charge you not that much, maybe $5 a month. You say, that's a lot of money to me. I know, so it depends. It really depends. And memory is big enough with the cloud memory. You can almost say that unlimited memory space. CPU is fast enough. CPU is fast enough to handle the apps, application, and comparing to your speed. Long time ago, like 40 years ago, I was waiting on my computer. My computer is slow, I'm faster. Today, computer is waiting on me. The difference is, when I was waiting on my computer, I complain. I say, hey, come on. Computer don't complain. We don't have an AI to make them complain yet. The port. Ports have two types of ports. One is serial port, one is parallel port. It's not like one is better than other. They are serving different purpose. So serial port is you have one line, you can send in info from point A to point B. Now you have two lines, you can send in info from point A to point B, point A to point B. Which one is faster? You would tell me. Two lines faster, right? Half goes through here, half goes through there. It's much faster. Yes and no. Yes, it's faster when you're doing a transport. But when you are doing assembly back, because you are putting the string of 0, 1, 0, 1, 0, 0, 1, 0, 1, 1, that makes sense. But if you chop it off to two portions, then via two portions, both portions go to the end destination. The info has been rearranged. It makes no sense. They need to arrange back to the original format so you can see it. That takes time. So you really want to save time here? We come with USB port. USB is a standard. USB 1.0, 2.0, 3.0. It's a standard. So you have a USB chip or thumb chip, USB port. Long time ago, we don't have it. We don't have it. The I/O speed is slow. We talk about CPU, we talk about memory. Now we are talking about I/O, input-output speed. If you are really use computers long time ago, you remember we have A drive. What's the A drive? That's a floppy disk drive. They have a floppy disk. You put the floppy disk in, limited info. Memory is small. Then you're going to hear the sound like, they found your stuff here. So that's very, very low or slow I/O, input, output. I use a floppy disk to output my info to the computer, and computer receive my input. Today we use a USB, a thumb drive. That's very, very fast. That's why we get rid of the A drive. You don't have an A drive anymore. You only have a C drive, that's your memory drive. You have a D drive, can be DVD or external drive. You never have a B, A, B, C, D, B drive. You just don't have a B drive. You have an A drive, we skip B. Then C drive, D drive, E drive, F drive, G drive, all those alphabet. We just don't have a B drive. If you ask me, why in the first place we don't have a B drive? Because B and D, A, B, B, C, D, D, pronunciation is so similar. You're talking to people say, hey, I got a problem, that's my B drive. People say, oh, you have a D drive problem. I said, no, it's a B drive. Oh, okay, you have a D drive problem. Oh. Well, I have enough alphabet, A, B, C, D, E, F, G. I just skip one, I'll skip B drive. So you have A drive for floppy, C drive, memory drive. Today we still have it. We still call C drive or your memory, your memory drive, and we have D drive, E drive. Once we use the USB port and USB chip to replace the floppy, we have much faster speed, and we have huge amount of info can be kept. It's even more portable. A thumb drive, you can put in your keychain. Floppy, you cannot. Floppy is like, I don't know, you never see a floppy disk here. Well, okay, it's kind of your credit card size, 2 or 3, double your credit card size, that's something like that. That's the size here. Yeah, so that's a little bit of computer hardware here, port here, USB port here. Nowadays, many computers have more than one USB port. Maybe here 4 or 5 here, that's USB. USB drive is for input and output. We have talked a little bit about that here. Talk about CPU and memory. CPU, see here, there's a picture, Intel CPU. Core i3, Intel. In the PC world, you want to get yourself a computer, they all have a CPU. How many companies making CPU? Intel, AMD. 2 companies are making CPU for PC. That's interesting. You go to a parking lot, you see so many cars. How many companies are making cars? You count it, Ford, Tesla, Toyota, Volvo, Mercedes, you keep counting, maybe 20, 30. How come they have more than 20, 30 companies making cars and only 2 companies making CPU? Even the CPU making is a money-making business. Why don't other people want to join? That's because the Intel has patents, many possible way to make CPU. And Intel allowed AMD to use their patents to come up with the CPU. So that's a patent practice. I myself, I have 5 patents for mobile phone, globally granted. A patent lasts for 20 years. So if you are an innovator, if you're a new one in the CPU field, you want to patent as many as possible. Your competitor also going to do that. It's nothing wrong. It's nothing wrong. That's a common business practice based on CPU. So if unfortunately one company have the major patent, then you need to get the permission, license fee to use that patent. Yeah, like CDMA for mobile phone, that's a Qualcomm patent. So if you want to use it, you need to get Qualcomm permission. And the company can say that, use it, I'm going to charge you for license fee. Or no, I don't want to let you use it. That's the business world. And after 20 years, everybody can use that patent, but wait 20 years. And probably no, so that's the world here. A company, a new company, you need to ask how many patents you have. Major patent, good patent, not like minor, tedious, trivial patents. Number and quality, they both count. So you need to have many, many good patents. So to keep the company, we call sustainability, to survive. Yeah. That's CPU. Intel CPU. Intel CPU is better than AMD CPU, a little bit faster and more expensive. That's your CPU. Cool. See here, Intel and AMD dominated the market for desktop and laptop computer. And I just told you why they are dominate the market. Because of patent, not because they can come up faster, they can sell you cheaper. No, not like that. Not really like that. If you can come out faster, other company can try to beat you. If you can sell for lower price, some other company can beat you as well. But if you have patent that for 20 years, then people cannot use the same way you have applied and been granted, we call patents, to do it. So that's the stuff. Yeah, I talk about the company Qualcomm. They have a CDMA, that's a mobile phone patents here. And we talk about that. Multiple cores here. You can consider the dual core processor. You can consider they have one CPU with 2 core, more powerful, or they even have dual CPU, 2 CPU. Your mobile phone needs much more powerful CPU comparing to your notebook. You carry your mobile phone 24 hours a day. You don't carry your notebook 24 hours a day. All the new good functions will come to your mobile phone first. Then your mobile phone with a little bit tiny space comparing to your notebook, it's really, really high tech. Mobile phone is really, really high tech. Notebook, desktop is not really, really high tech. CPU, go say clock rate, like gigahertz. How fast means how powerful. Using a car, you have a sports car, then how many horsepower you have for your engine. You said that about 250 horsepower. Yes, you have the sports engine. You said that's about 120. No, you don't have a sports engine. So that's how fast is your engine, or how fast is your CPU. We need to have a way to measure. And the way to measure is gigahertz. Yeah, per second. Gigahertz, that's very fast. Thinking about vibration. You use your hand here, you can vibrate, right? Okay, faster. You're much younger than me, so you can vibrate very, very faster, right? But is that gigahertz? No, of course not. Right? In 1 second, you can probably vibrate 3 times, 4 times, that's it. And a computer can vibrate gigahertz. So that's calculation. Computer can calculate very, very fast. Long time ago, computers are slow. Accurate, but slow. Accurate means if human being program with errors, then the computer will give you a so-called junk in, junk out. Otherwise, the computer is accurate. Accuracy. In this case means the computer did what was told by you. Okay. Memory, see the memory chip here, RAM. We talk about RAM, we talk about ROM. So RAM here, like temporary workspace to keep your homework assignment. When they say temporary workspace, you need to save your work. From time to time, you want to keep saving. Otherwise, something went wrong, you're going to lose all of your work. It's just a common practice, a good practice. Like every 2 hours, maybe 1 hour, save your class work. You say, whoa, I worked 10 hours, now I lost all the 10 hours work. I have to restart it. That's another 10 hours. Yes, you learn the hard way. We all have learned the hard way. So that's your RAM here. Memory module here. It's RAM here. They're talking about different type of RAM. Remember we talked about RAM and ROM here. ROM keep your Windows 10. That's for CPU. And this RAM is also for CPU, not for you. You need to have a big RAM. Then the fast CPU will have big space to work on. Talking about RAM and ROM. Yep, that's the basic idea here. Talking about read-only memory, that's ROM. Like this is a BIOS here. So what is a ROM? I told you, what is the non-volatile? Volatile means if I power off, would you lose the info? ROM, no. You power on, power off, I still have my Windows 10 OS installed. RAM, you power on, power off, I haven't saved my class work. I lost it. So that's volatile and non-volatile. And we also have firmware. I talk about firmware here. Software, you have burned into hardware to handle much faster. And BIOS here is how you're going to upgrade your, say, Windows 10 later on, maybe Windows 11. How are you going to change it? The BIOS. Once you power on, you may be doing some function key, like function 10 or function 2, I don't know. Then you stop to bring up the Windows 10. You can say that, hey, don't go to the ROM to bring up the Windows 10. Now I have a new Windows 11. I want to install from a different port. So that's what you do here. Then you can change. Otherwise, you can never change. Cache memory, that's for CPU to use. It's a much faster memory comparing to a normal RAM memory. You get yourself a CPU, they say it's much faster CPU because have a bigger cache memory. So that's a different type of memory and it's going to cost you a little bit more. Virtual memory. Virtual memory here, this term have many different meaning. You need to be careful when you are using this virtual memory and people are using in a different way, then you cannot have a good communication. Virtual memory in one way is called shared. That's called virtual memory. For instance, there are 4 schools. Each school, they want to have some memory so they can use. So, but Sometimes school A run out of memory, and school B, they still have many memories unused. Can we make it virtual memory? Sure. So school A and school B, they are sharing the memory. Then you tell school A, you have this big of memory. Telling school B, you have the same, this big of memory. But actually, they don't. Maybe you say, hey, you have 100, you have 100. Maybe they don't. They only have 90 and 90. So what are you going to do? So when this school using out the 90, hopefully that other school still have something available. Then you borrow 10 from that school. Okay, yeah, you have 100, as I told you. Two schools may not be able to see the significance of this idea. Say 100 school. Now your chance is much better, right? I told you you have 100 memory space. That's virtual memory. You actually only have 90. Once you are running out of 90, you're going to get a 10. I have 99 other schools' memory I can borrow. The chances are, most likely I can borrow 10 from some unused memory school here. So I just use it here. Hey. And also, I don't guarantee you 100%. Most of the time, 95%, you're going to have that. If 5% you're out of luck, then you don't have that 100 virtual memory. So that's like a business practice or better use of resources we call virtual memory. Yep. Yeah, that's what I want to talk about CPU and memory. Still want to remind you, nowadays, CPU is fast enough, memory is big enough. The improvement you're going to see mostly will be I/O, input, output, like a fingerprint or facial identification, that's input, output. Your facial, how you look, or your fingerprint, got nothing to do with CPU or memory. So we are going to see more and more improvement in this I/O field.